Okay, so in today's lesson, we're going to be learning about something called implicit differentiation. So the first thing we need to think about is the word implicit. If you think about the word explicit, that means something that is in your face, it's obvious. If someone explicitly tells you something, then they're telling you directly. Whereas implicit means that it's something you kind of read between the lines. It's the opposite of straightforward. So today we're going to learn about how to differentiate in a backwards kind of way. So to make this, to have this make more sense to you, imagine we have the function xy equals 1. Now right off the bat you're going to notice that that function is strange because normally we have functions where we have one variable isolated. In this example, it's pretty easy to get one of the variables by itself. We could divide by x on both sides and get y equals 1 over x. This is implicit, and this is explicit. So this one, the variables are mixed together, and in the explicit one variable is set apart. It's isolated, and the rest of the equation is of a different variable type. So far, we've only differentiated explicitly. We could easily differentiate this 1 over x using the power rule with a little bit of work. But now I'm going to teach you how to differentiate implicitly the way this is right here. Now, some of you may be wondering, why would we ever learn to do it this way if we could just solve for a variable? Well, I'll give you an example of one that you can't separate the variables. Say we have x squared plus y squared minus 4x plus 5y minus 8 equals 0. Now that's a little bit of overkill because just by doing x squared plus y squared, that would make us unable to solve for one variable or the other. But with all this other stuff thrown in, there's no way to get just x or just y by itself. So we have to use implicit differentiation. So I'll show you with this big long example what we're supposed to do. First of all, each term is going to be a little bit different. We are going to use a different type of notation when we do the derivative. Typically, we just do the derivative. But now we're going to actually do this. We're going to say that we're doing the derivative d over dx. That just means doing the derivative. It doesn't tell you with what variable you're doing it with respect to. So we're just doing the derivative of the left side and the right. Okay. And whenever we do this derivative, we're doing it with just respect to x, but the top, notice it's just a d. That means that we don't know what variable we're doing yet because each term is going to be different. So with this first term, the derivative is going to be the derivative of x with respect to x. So dx over dx when you do the first one. And so you're just going to have 2x as your derivative. No notation behind it because you did dx over dx, which is, they cancel each other. Now when we go to the next term, the derivative is with respect to y, or it's going to be the derivative of y with respect to x. So we're going to say 2y using our power rule, but then afterwards we're going to have to put dy over dx to signify that we did the derivative of y with respect to x. Notice the difference. This one we don't have any notation because we did the derivative of x with respect to x. But here we did the derivative of y with respect to x, so we have some notation. Next one, again, we're doing the derivative of x with respect to x, so we'll just have minus 4 using the power rule. The next one is going to be 5, but since we were doing the derivative of y, we'll put dy over dx. And then the last one, negative 8, turns into 0, so we don't even have to write it down. And then over here, the derivative of 0 is 0. But since it's the only thing on the right side, we do have to write that one down. Okay, so the notation was the important part here. Notice the difference. I'm going to use some highlighting to help me out. Notice that this one was a y term, so we had to use the notation. And this one was a y term, so we had to use the notation. Now these other two just had x's in them, so whenever you went and did the derivative, there is no notation that follows them. So that's the first step. Step 1 is to differentiate each term. Now we're going to move into step 2, and step 2 is to put all of the dy over dx terms together and all of the non-dy over dx terms on the other side. So step 2 is going to be to combine like terms. So we're going to leave our 2y dy over dx and our plus 5 dy over dx on the left, and we're going to move our 2x and our negative 4 to the right so that we have negative 2x plus 4. Okay, now at this point we want to factor out our dy over dx. That's step 3. So we're going to have dy over dx, and in parentheses 2y plus 5, and then of course our negative 2x plus 4. So that was step 3. We factored out dy over dx. Why would we do that? Because that stands for the derivative. So if we can isolate that and get it by itself, that will give us our derivative. So now we're going to divide by 2y plus 5. And so our final answer, our derivative, dy over dx, is negative 2x plus 4 over 2y plus 5. And that is our final answer.